Okay, so today we are starting to talk about equations of lines, which this is one of the most important concepts in pretty much all of the course. So solving equations, writing equations, graphing equations, and factoring equations are really the four most important things in all of algebra. So this is way, way up there in level of importance. So please, please, if you're struggling, reach out because you need to get help so that we can make sure that you know how to do this. So today we are starting with a form that you're definitely familiar with, which is Slope-Intercept Form. And then we're also introducing what is called Point-Slope Form. So these are for linear equations, so equations that if we graph them would make a line. And so these are just two of the forms. We're also going to learn standard form a little bit later. So slope-intercept form, you've already seen. It's definitely in your junior high standards. It's y equals mx plus b, where m is the slope of the line, and 0b, this is an ordered pair, is the y-intercept. Remember, we always write intercepts as ordered pairs. So don't just look at the b and say, oh, that's the y-intercept. The y-intercept should always be listed as an ordered pair. So the first thing we're going to do is take this slope-intercept equation and we're going to create a table of values. Then we're going to use that table to plot the points and graph the line. So I've been given the x's, so I'm going to plug those in to find the various y's. So I left some space out here so that we could have room to kind of write it out. So it's -2 times -2, since that's what I'm plugging in for x, and then +9. So -2 times -2 is +4, +9 gives me 13. Next, I plug in 0, so -2 times 0 plus 9. So 0 plus 9, which is 9. Now I'm going to plug in +2. So -2 times +2 is -4. -4 plus 9 is 5. Moving right along, plug in 4. -2 times 4 is -8, plus 9 is 1. Now, -2 times 5 plus 9. So -2 times 5 is -10, plus 9 gives me -1. So now I have a list of 5 ordered pairs. Because remember that a table is really just another way of writing ordered pairs. So if I plot these points, I would have -2, 13. So here's -2 all the way up to 13. Then I've got 0, 9. Then I've got 2, 5. 4, 1. And last but not least, 5, -1. Now, I'm going to apologize because it's really hard for me to connect dots using what I use to write when I record these videos. So if this doesn't exactly look like a line, I apologize. That's not too bad. Got a little wonky over here, but the first beginning part of it looks good. All right, so part A, explain how to find the slope from the table. So you should definitely know this. This is what we did way back in section 9.1. So about a week it's been since we did that. So you should say use y minus y over x minus x. That is how we find the slope from the table. So that is the first thing that I want you to do is go ahead, calculate using any two of these points. Doesn't matter which ones, but find the value of the slope. All right, so when I find the slope here, I'm going to go ahead and choose these 2 points here, just because I didn't want to include negatives, and these two don't have negatives. So I'm going to do, second point is 2, 5, so I'm going to do y on the top, x on the bottom, and then I pick my other point, so minus 9 for the y, 0 for the x. So 5 minus 9 is negative 4, 2 minus 0 is 2, and negative 4 over 2 is negative 2. So the slope of this line is negative 2. Excuse me. That should make sense because we learned in the lesson for section 9.3 that negative slopes should fall, meaning that they should move down as you trace from left to right like you'd be reading. So we should expect to have a negative value from there. All right, next question. Explain how to find the slope from the graph. So hopefully you remember from that first lesson on slope that slope from a graph we find using rise over run. So when I go to do that in this instance, I can draw my triangle. Again, it doesn't matter which points you use for your triangle, but I'm using these ones. This is my rise. And since I moved down, I know it should be negative. So negative 1, 2, 3, 4. My run is 1, 2, which again gives me that exact same slope, which I should know because slope is constant. All right, next, explain how to find the y-intercept from the table. So what you should be doing is look for the row where x is 0 and write as an ordered pair. So that's how we should find it. So I want you to go ahead, look for the row where x is 0, and write that y-intercept as an ordered pair. Right, so your answer here should be 0, 9. That is our y-intercept. For D, explain how to find the y-intercept from the graph. Look for the place where the line crosses the y-axis. And again, write it as an ordered pair. So look, right here, crosses the y-axis. That point is left and right 0, up 9. So of course, we get the same answer that we did in C. So you can find the equations slope and y-intercept from both a table, from my graph, and then again, let's connect this to slope-intercept form. Look at this equation. M is my slope, negative 2. 0b is my y-intercept. B is 9. So 0, 9 should be my y-intercept. Now we've connected the equation to everything we know about slope and y-intercept from before. All right, example 2. Monica gets on an elevator in a skyscraper. The elevator starts to move at a rate of negative 20 feet per second. After 6 seconds on the elevator, Monica is 350 feet from the ground floor of the building. So we've got a couple things going on here. First, in A, the rate of the elevator is negative. So we need to know what this means in the situation, meaning in real life. What does the fact that it's negative tell us? What is the elevator doing? Hopefully you said it's negative because the elevator is moving down. Now, it wants to know what value in slope-intercept form of the equation does the rate represent. So the rate, remember we discussed this already, the rate of change is the same as slope. So the rate is the slope, which is m. So it's m in the equation. B, how many feet was Monica above the ground when she got on the elevator? Show how you determined this. So when she got on the elevator, that would be her initial amount. Which they don't tell us that, but they do tell us that after 6 seconds, Monica's 350 feet from the ground floor of the building. So that means, so because I don't know it, I'm just going to make that a variable. So let's just call it X for right now. And I know that wherever she started, that she's going down at a rate of 20 feet per second. And it says after 6 seconds, so per means to multiply, that she's 350 feet. So where she starts, minus 20 times the 6 seconds, lands her at 350. So if I solve this equation for my x, just my variable that I used to plug in, that's going to give me how many feet above the ground she was. So 20 times 6 is 120, so x minus 120 equals 350. And so then I would add 120 to both sides of the equation, and I get 470. So 470 feet is how far above the ground she was when she got on the elevator. So now the question is, always relating it to real life, what value in slope-intercept form would this answer represent? So the way you need to think about this is when she gets on the elevator, that means her time is 0. She's been on the elevator for 0 seconds when she first gets on. And when that value is 0, that represents my y-intercept. So this is the y-coordinate of the y-intercept, which means b in the equation. So b in slope-intercept form is what it wants to know here. All right, write an equation in slope-intercept form for the motion of the elevator since it started to move. So we do y equals m, which we already said m is the rate of the elevator. So -6 mx plus b. So b we said was 470. So what do x and y represent? So y is where we end up. So this is, y is feet from ground floor. And x is number of seconds on the elevator. So when we put in how many seconds we've been on, that helps us figure out what our distance from the ground floor is. So now in part E, once we've written an equation, the purpose of that is to use it. So we're going to determine at this rate how long it will take after Monica enters the elevator for her to exit the elevator on the ground floor. So what I want you to realize here, on the ground floor means that y is 0. So what we need to do here is we need to plug in 0 for y and solve, because it says how long. We're solving for x. So plug 0 in for y and go ahead and solve for x. It's okay, it's a real life situation, so it's okay to use a decimal here. But go ahead and do that, plug in 0 for y, and solve for x. All right, so let's check your work here. If we plug in 0 for y, we've got 0 equals negative 6x plus 470. So I want my variables and my constants to be on opposite sides when I solve equations. So I'm going to move this subtracted 6x by adding. Those cancel out. 0 plus 6x is just 6x. So I have 6x equals 470. So then to get x alone, I would need to divide both sides by 6, which does not come out nicely, so I'm using those squiggly equals because that represents approximately, because I'm going to have to round. 470 divided by 6 is about 78.3. Do not forget that when you put a word problem that you're going to need labels. So 78.3 seconds is what I'm going to need here. Okay, the other form we're going to study today is point-slope form. So slope-intercept form is y equals mx plus b. Point-slope form is right here. Y minus y sub 1 equals m times x minus x sub 1. In this formula, m is still the slope, but x1, y1 represents a point that's on the line. So in example 3, we're going to write the equation of the line with slope of 1/2 passing through the point 2, 5. So this tells me 1/2 is my m and 2, 5 is my x1, y1. So the first thing I'm going to do is just substitute those values into my point slope form. You are not substituting for the plane y and the plane x. Those are our variables. So y minus y1, which is 5, equals m, which is 1/2, times x, which stays x, that's my variable, minus x1, which is 2. So this is the point slope form. So plot the given point on the coordinate grid because I want to graph the line too. So when we're talking about point slope form, first thing I'm going to do is plot that point. So 2, 5 is right here. Then I'm going to use the slope from that point to find another point. So my slope is 1/2. So 1/2, because that's rise over run, and they're both positive values, that means that I can rise 1, which means go up 1, and run 2, which means right 2. So up 1, right 2, and I can plot another point. I can continue with that pattern if I want. Rise 1, run 2. Rise 1, run 2. So on and so forth. You could also, because -1 over -2 is also 1/2, I could rise -1 and run -2, and notice that that's still on the same line. Then, of course, I can connect my points to make my line. Sorry about the curvy connection. Okay. What I would like you to do now, following my model here, is to use this point and this slope to write a point slope equation. The one thing I want you to be careful of, this guy's negative, this is my x1, this is my y1, this is my m. Remember that what we do when we have minus negatives. So go ahead, take a minute here and write the point slope equation using this point and this slope. All right, so checking your answer here, I have y minus y1, which is 7, equals m, which is 2/3, parentheses, x minus x1, which is -2. So minus -2 becomes a plus 2. So y minus 7 equals 2/3 times x plus 2. All right, example 5. Identify the slope and a point on the line for each equation. So this is just working backward. I have the equation. I want to identify my point and my slope. So because it's always minus in the equation, if it's a minus, that means that my point should be positive. If it's a plus, that means it's negative. So my x1, y1, x1 here, because that's minus, that means that this was positive, x minus x1. And then here, this is positive, so that means that should be a minus. So y minus -4 is how I got this. So this is my point, and then my slope should be my m, in this case, 3/8. All right, I want you to go ahead on part B and identify for me what your ordered pair, what your point is on this line based upon this equation that you're given. All right, my x value, it's a plus, which means it should be a minus in here, -3. My y value is negative, which means it should be positive in here. So -3/6 is what you should have had there. Slope, that's the easy part. Just copy what's out in front. All right, example 6. Now we're using this line that's graphed. Notice that on this graph, I can't see the y-intercept. So using slope-intercept form really isn't an option here. So in order to still write the equation of the line, the first thing I need to do are list 2 points that lie on it. So I can tell this guy right here is an exact point, and then this guy right here is an exact point. So the ordered pairs, this is 2, 2, and my second point is 3, 7. Once I have those 2 points, I can then calculate the slope from the slope formula, or I can use the rise and run on the graph to calculate. So I'll do it really quickly both ways, doesn't really matter. So if I start with this point, y, x, so y minus the y here over x minus the x there. So 7 minus 2 is 5, 3 minus 2 is 1. So hopefully I get a slope of 5 when I count rise and run as well. So let me just draw out that triangle. My rise, 1, 2, 3, 4, 5. My run, 1. So yes, I've confirmed it. It does give me the same thing. All right, so now I know the slope of the line, and I know 2 points on the line. So that means that I can write the equation in point-slope form just like we did before. So using the first point, it would be y minus y1, which is 2, equals my m, which is 5, times x minus x1. Using the second point, same idea, y minus 7 equals 5 times x minus 3. So, 2 totally different looking equations other than the slope, but they are the slope for the same line. Example 7, write the equation of the line that passes through -3, 3 and 7, 5. So, in point slope form, we have to obviously calculate the slope first. So I'm going to start with this point. So y is 5, x is 7 for my slope formula. Y here is 3, Here it's -3, which means this guy turns to a plus. 5 minus 3 is 2. 7 plus 3 is 10. And 2 over 10 reduces to 1/5. In point slope form, you could choose either of these 2 points to use. I am going to choose this one that I already have underlined because it doesn't have negatives, and I like working with positives better. So y minus the y1, which is 5, equals my m, which I calculated as 1/5, times x minus 7, because that's my x1. This is point slope form. Now, if I have point slope form and I want to make it into slope-intercept form, all I need to do is distribute and get y by itself in my point slope formula. So, distribute, I'm going to rewrite it here. Distribute here, so that gives me 1/5 x minus 7/5, and then get y alone, so I distributed. Now I get y alone by adding 5 to both sides. Here, you'll want your calculator there since we're adding fractions. I know it's 1/5 x. I don't have my calculator right this second, so I'm just going to find a common denominator. So 5 is 25/5, and I'm taking away 7 from that. So the 5 plus 2 more, which would give me 18. So plus 18/5. And again, if you have your calculator out, just do -7/5 plus 5 and press equals. It'll give it to you in your fraction form there. All right, last example. The town of San Simon charges its residents for trash pickup and water usage on the same bill. Each month, the city charges a flat fee for trash pickup and a fee of 25 cents per gallon of water used. In January, one resident used 44 gallons of water and received a bill for $16. If X is the number of gallons of water and Y is the bill amount in dollars, write a point XY given in this problem. So here you are given the information to write an ordered pair of a point. So go ahead, write out what that ordered pair should be based on this underlined last sentence. So really here, this is just matching. X is the number of gallons, so it says 44 gallons, that's our X coordinate. Y is the bill amount in dollars, so that'd be 16. So 44.16 is our ordered pair. B, what does the 25 cents per gallon represent? Well, this guy is a rate of change, right? 25 cents per gallon. Remember that rate of change is the same idea as slope. So the slope of the equation is what the 25 cents per gallon represents. So now I have a point, I know the slope, so now I can write my equation in point slope form. So y minus y1, which is 16, equals my slope, which is 0.25, times x minus the x coordinate, which is 44. All right, D, write the equation in part C in slope-intercept form. So just like I did up here in B, that just means I'm going to distribute and then I'm going to get y by itself. So to distribute, 0.25 times x is 0.25x. 0.25 times -44, again, you can use your calculator if you want, but this is 1/4. A fourth of 44 is 11, so that one I just kind of know. So I distributed Now I need to get y alone. So add that 16. I get y equals 0.25x plus 5. So this is the first part. This is my y-intercept. Now the big idea, what does this y-intercept represent? So think about y-intercept is when x is 0. So means if water usage was 0, the charge would be $5. Now, this also, remember, would represent a flat fee. Look at what's given to us in the problem. It says the flat fee is for trash pickup. So that means the y-intercept is the flat fee that is charged for trash pickup, which would be $5. So if it asked you, how much is trash pickup, we could give that answer. I wish my trash pickup was only $5. That is pretty cheap. Okay, so hopefully you feel like you have a pretty good grip on slope-intercept as well as point-slope form. We'll be doing a lot more practice with those in the next week or so.